Suppose a bag has two different colors item. One is they have 5 red items in a bag and they have 3 blue items in a bag, so making it altogether 8 in total. So now the question is, you have to find the probability. So find the probability. So now you have to find the probability. So one item is chosen. So one item is removed. So one item is removed. You have to find the probability. So question number A, that it is red. So if one item is removed and to find the probability is red, this is very, very simple. As you know, the rule of probability is number of event divided by total number of outcomes. So this is event, this is sample space. So we know when we are finding the probability of one red, you write it like this: probability bracket open, you write the capital letter, that is one red, and so total number of item is 8, and there are 5 red. So that's it. That's very, very simple. So question number B, find the one item is removed. Find the probability it is blue. So this is going to be, there are altogether 8 items and there are 3 blue, so 3 by 8. So this is very, very simple. The question mainly that's going to be is 2 items are removed. 2 items are removed. Now one thing must be clarified. What does it mean removed? Removed means not replaced. So when objects are being removed, they are not being replaced. So you have to understand the difference between the probability of a trial experiment, where if the probability of getting ahead is suppose half, meaning 50%, it will always be the same. No matter how many times you're tossing the coin, it will always be 50%. But here, when you're taking 2 items and it is not replaced, remove means not replaced, that means the probabilities are going to change. Okay, so here goes. So this is the first time. So 2 items are removed, not replaced. So what is the event? So the event is going to be, the first one is red and the second one is red. So both red. So both red, there is no permutation happening over here. Both red means RR, red and red, and it is written like this, RR. So when you write the 2 letters side by side, in terms of probability terminology, RR means AND rule. So we are going to use the AND rule. That means you multiply each probability. But one thing you have to be careful over here, because the probabilities are changing. The first time you get the probability, you already know it's 5 by 8. So there are 8 items. Out of this, you're getting 5 red. So 5 out of 8. But and mean multiplication. But now you have already removed the red. So now there are 7 items. And now there are 4 red because 1 item has been removed. So this will be 4 by 7. So when you do this draw experiment, you have to remember, since objects are being removed, that means every time you remove an object, you're not returning it. So the bag is becoming emptier. So when the question is both red, that means red and red. By the way, both red has no permutation. Permutation means different ordering has to be considered. So there is no other order. Red and red has no other ordering. So RR means red and red, and means multiply the probabilities. But remember, this is a draw experiment, so the probabilities are going to change. Okay, now the next question. Suppose the next question is both blue. So both blue means blue and blue. The first one is also blue and the second one also blue. This one also has no permutation, meaning no ordering is necessary, because B, that doesn't have any difference. So B, capital B means blue, and then beside it to write capital B, that means you're writing AND rule, blue and blue. Okay, so we know event by total outcome. So total number of items, there are 8 and there are 3 blue. And so now you have to, by and you have to assume 1 item has been removed, so the total is now 7, and this is going to be 1 blue has been removed, so it should be 2. So the probability is 3 by 8 multiplied by 2 by 7. That's the difference. That's the difference between a trial experiment and a draw experiment. In a draw experiment, you're removing the item. The probability is not constant, it's changing. Now in question number In question number C, the question is same color. Same color. Now we have permutation over here. Same color. So you're removing two items and they have to be same color. So they can be red and red, or they can be blue and blue. So now we have permutation for the first time over here. So we have two different situations. So when you're removing two items and you're picking same color, that means red and red or blue and blue. So that means again we are removing the items. So red and red would be 5 by 8 into 4 by 7, or blue and blue is going to be 3 by 8 into 2 by 7. So that's it. That's how we get this permutation. So here we have permutation. So if the question is find the probability that there is one red and one blue, we do not know what order it is. So again we have to use the concept of permutation. That means it can be red and blue, or it can be blue and red. But the thing is, the permutation, each permutation has the same probability. So we can consider if this probability is P, then this total probability will also be P. So it's the same. So instead of adding P plus P to P, we can just write down the first probability. So there are 5 red out of 8 items, and now one red has been removed, so there are 7 items, but there are altogether 3 blues. So this is red and blue when items are removed, not replaced. So instead of doing this, we can just write into 2, because the probability for this is also the same, because now the first one is blue. So 3 blue out of 8, and we have 5 red out of 7 because one blue has been removed. So if you take a look over here, in the denominator we have 8 and 7, 8 and 7, and in the numerator we have 3 and 5, 5 and 3, same thing. So we don't have to write this again. Every permutation will have the same probability. So all we have to do is take the first one, and if for each and every different probability we can just multiply by that, because multiplication is basically addition. The question might be, so find the probability that there is at least one red. Now at least one red means what are the possibilities, each and every possibilities. We can have red and red, or we can have blue and blue, or we can have red and blue, or we can have blue and red. There are no other possibilities. These are all the possibilities. So in here, at least one red, everything is at least one red, at least one red, at least one red, except for this one, blue and blue. So there are two ways of doing this. One is using the long way. We can just find the probability by taking each and every one that fits this description. So red and red, or red and blue, or blue and red. So we can take each and every one of them. So red and red is 5 by 8, and the next red is 4 by 7, and red and blue, blue and red is 2 into, we just found this, 5 by 8 into 3 by 7. The same thing can be done using the NOT rule. The NOT rule simply says, when you take the total probability and remove whatever is not needed, you will get the rest of it. So there are two ways of doing same math. Instead of adding each and every one that we want, we can just say probability of at least one red means from the total probability it is not going to be blue and blue. So not blue and blue means at least one red. So this means from the total probability, all these four things together is 100%. Total probability, subtract blue and blue, which is there are 3 items, that is blue out of total 8, and 2 by 7. So this value is equivalent to this value. They're the same. So it is much easier to use the NOT rule when you have to choose from something that the total is 1, and all you have to do is remove one item and the rest is the same. So this is the technique when you are removing 2 items and you need at least one. Just from the total probability, just subtract the one that is not needed.